Okay, today what we are looking at is we're looking at the last part of 3.3, and it is I can solve exponential equations. So what happens with solving exponents and equations is this time the exponents are the actual part that we're going to be doing. So let's take a look at this first of all. So what is the value of x? If x to the power of x equals 4 to the power of 3. So 4 to the x equals 4 to the 3. Well, then I think that most of us would agree that that is fairly simple. It doesn't require a whole lot of teaching on my part. You know that that equals x would equal 3. Now, exactly why does it equal 3? You're saying, well, it's pretty common sense. Well, in fact, in general, if the bases are the same, such as they are here, 4 equals 4, then that means that the exponents also must be equal. Okay, so if bases are the same, okay, and we have the equal sign here, then the exponents must be equal. So let's take a look at some examples and see if they get any harder than that. So we're going to look at a working example first of all. Okay, so we have 9 to the power of x minus 3 equals 27 to the power of 2x plus 3. Well, first of all, my bases are not equal. We all agree on that. So the first thing that I would need to do is I would need to bring this over here, make the bases the same. Okay, so when we're talking about making the bases the same, I have a 9 and a 27. In most cases, well, in a lot of cases, I try to see if I can turn the larger number into the smaller number. So can I change the base of 27 into 9 to the power of something? No, I can't. So what base could I use for both a 9 and a 27? And hopefully you said that it was 3. So what we're going to do is we're going to use the power to power property to make the expressions equivalent to each other. So what we're going to do is we're going to take that 9 and we're going to change 9 so it is 2 squared. Sorry, 3 squared. And I'm going to change the 27 so it is 3 to the power of 3. Okay, so I'm replacing 9 with this, and I'm replacing 27 with this one. So we end up with 3 squared, but that 9 was to the power of x minus 3. And our 27 we changed to 3 cubed, and that is to the power of 2x plus 3. So what this step says is we're going to use the power to power property to make them equivalent. Okay, so what we have to do, power to power means I multiply. So I have to multiply the 2 by the x and by the negative 3. So I end up having then as my answer here, 3 to the power of 2x minus 6. And on the right-hand side, I end up with 3 to the power of 6x plus 9. Now you can see our bases are the same, and we've used the power to power property to get our exponents into the equivalent form. Now let's take a look. State therefore, okay, and that's just our 3 little dots that we're going to use. So we would do therefore, and we know therefore those exponents must be equal. So there we have, therefore we're going to solve for the variable. So we're going to put therefore, and we're going to then take our exponents from the first one, which is 2x minus 6. That must be equal to 6x plus 9. And the reason? Well, the same reason for what does x equal here? Our bases are the same, therefore those exponents must be equal. So this obviously equation, I have to do a little bit more work than the one at the top. So let's take a look at it. So I want to get all the x's to one side, so I'm going to subtract 2x from both sides. And so I'm going to have negative 6 equals 4x plus 9. I'm going to subtract 9 from both sides, so I end up with negative 15 equals 4x. and obviously divide both sides by the 4, so I end up with x equals negative 15 over 4. And I would leave it like that. I wouldn't change it to a decimal. Okay, so that's pretty much the steps for everything. So let's take a look at more examples. All right, so I'm just going to put the blind up so we're only looking at 2 at a time. So let's look at the first one. First one's pretty easy. So I need to first of all make sure that, I'll get back there, make sure that my bases are the same. Well, 2 equaling 2. So that means already, therefore, x plus 4 must equal 7. Solving for x, subtract 4 from both sides, so x equals 3. That's simple. Okay, the next one. My bases are not the same. I can turn the 8 into a base of 2. So I have 2 to the power of 5x plus 1, and it equals 2 to the power of 3. Okay, my bases are the same, therefore my exponents must be equal. So 5x plus 1 equals 3. Subtract 1 from both sides, 5x equals 2, and divide both sides by 2, so x equals 2/5. All right, and moving down to the next set of examples. Okay, so the next one, 5 and 25. Well, obviously the base that I want is going to be 5. So this is 5 squared. So I end up again with 5 to the 3x minus 4 equals 5 to the power of 2, and it's all to the x. So I can just save that and put that like that. My bases are the same. Therefore, the exponents must be equal. Okay, and getting all the x's to one side, so I have x minus 4 equals 0. And finally, I have x equals positive 4. Next one, very similar to the working example, I have 27 and 9. Again, I'm going to change them to bases of 3. So 3 squared is the same as 27. And 9 is the same as 3 squared. And that's to the x plus 1. Use my power to power rule. I know that's 3 to the power of 12x minus 3, and that equals 3 to the power of 2x plus 2. And now my bases are the same, therefore the exponents must be equal. And you'll get sick of me saying that, but you'll remember it. Okay, and again, now what we need to do is we need to get all the x's to one side, so subtract 2x on both sides. So I end up with 10x minus 3 equals positive 2. 10x equals 5. And finally, divide both sides by 10, and so I end up with x equals 1/2. Okay, let's look at the next two. Now the next two are a little bit different. Okay, the reason they're different, okay, this is 10 to the power of 4x plus 8. This one's a fraction. Uh-oh. Okay, so what I can do is I can use an exponent law in order to flip this. Okay, so we know that an exponent, a negative exponent, flips the base. So that's the first thing I'm going to do here is I'm going to flip the base. So I have 10 to the power of 4x plus 8. And that is right now equal to 100 to the power of negative 1. Now, the reason I can do that now is now I can turn 100 into the base of 10. So we had 10 to the power of 4x plus 8 equals 10 squared, and that is to the negative 1. So this really is 10 to the negative 2. And now my bases are the same. Therefore, the 4x plus 8 equals negative 2. Again, solving for x, We're going to subtract 8 from both sides. We get 10. So we end up with, in this case, and I'm just going to move that down a little bit, and I'm going to move that out of my way. So when I divide both sides by 4, what's going to happen? I'm going to have x to the power of 10 quarters, which is the same as 5 halves. Okay, so you can use the exponent laws to suit your purpose. So in this case, I didn't want a fraction, so I made it so it wasn't a fraction. Now, what's different about this one is a couple different things. First of all, it's not set up like all the rest. All the other ones had a base, a power equals another power. Okay, here I have 2 terms on this side and 0 on this side. So the first thing I'm going to do is I'm going to add 1 to both sides. By adding 1 to both sides, I end up setting it up at least so that I have a number equals a number. Now, bases are not the same here. So how do I make the bases the same? Well, I can use another exponent law that says any base to the power of 0 equals 1. So I can turn this 1 in this question to 8 to the power of 0, okay, because that suits our purpose. Now, if this had been 16 to the x plus 5, I would change the 1 to 16 to the 0. Okay, so kind of an important little example here. You might want to keep track of that for a certain purpose, which you know is usually tests. So we're going to keep 8 to the x plus 5, and we're going to change 1 so that it's 8 to the 0. The reason being 8 to the 0 does equal 1. Okay, so now my bases are the same. They're both 8. Therefore, it means that x plus 5 must equal 0. Therefore, we have our x equals negative 5. Okay, so that's the last kind of working with exponent laws. So what you have to do is a worksheet dealing with this. Okay, it's really not that bad. I've done a lot worse things than this.